and good day, pre-algebra. We are about to start PO42, which is solving a proportion using equivalency and cross products. So cross products is something that we talked about in CO41. We used it to determine whether or not two values were proportional. You weren't told, okay? Here, notice that I'm telling you 12/13 is equal to 30 over something, right? We don't know what that something is. That's our goal today, is going to be to solve for that something. And one method we can use is cross products. You've solved for variables in fractions before using equivalency, using scale factor. So this objective is primarily going to focus on cross products. And as a review, what does cross products tell us that we can do? What's the whole gist behind cross products? What's the whole gist behind cross products? Anyone not get this sheet yet that wants it? Going once, going twice? Okay. You haven't got it? What's the deal behind cross products? Kind of in the name, cross products. Cross products tells us that if we've got two values that are in fraction form, we can determine equivalency by multiplying in a cross-like fashion. That the product of 12 and n is going to be equal to the product of 13 times 30. Now in C41, we knew what n was, right? And so we more use this as a way to determine whether or not these values were equal. If the products of each of those were the same, then that was a yay. If the products were different, then it was a nay, right? Here, I'm telling you that they're equal. That's what the equal sign is there for. I'm telling you these two fractions are equal, but we're missing a piece of it. We're missing the denominator of that second fraction. But we can use that idea of cross products to help us solve for it, because knowing these are equal, we know that this product, 12 and n, has to equal the product of 13 and 30. It's a mathematical law. Can't argue with it. So 12 times n is written as 12n. 13 times 30 is 390. How do we solve for n in this equation? 12n equals 390. What do we do to solve for n? Annika? Exactly. It's a one-step equation. Divide both sides by 12. On the left side, that gets n by itself. And 390 divided by 12 is 32.5. Okay? And what that tells us is that 12 over 13 is equal to 30 over 32.5. That's what we just did here, right? We figured out that the denominator of that second fraction, to make these two values equivalent, has to be 32.5. Now, question for you. How could you check that to make sure that you did your math correctly and that these two fractions are indeed equivalent? Yeah. Add 3? No, we're not going to add 3. John said use math. John, what math are we going to be using here?
I said math way.
A math way?
Oh, never mind.
Okay. Annika, we could do another strategy, right? We already know, we found our answer using cross products here, so we could use another strategy to make sure that these indeed are equivalent fractions. I don't like scale factor. 12 doesn't really go into 30 evenly, okay? And so let's use the decimal comparison. If we take 12 divided by 13, we get 0.9230769,231. Long, nasty. But if we take 30 divided by 32.5, we get the exact same thing, okay? So it's a quick, easy check to make sure you did your math correctly. Questions on that process? Is this a review from last year? Somewhat? Maybe kind of, sort of? I hope so. Good. All right. Next one here. N over 15 equals 8 over 21. Our n is in a different spot now, right? In the first one, it was in the denominator of the second fraction. In this one, it's in the numerator of the first fraction. Does that make a difference? No. Can we still use cross products to solve for n here? Yes. Especially since 15 doesn't go into 21 evenly, right? So scale factor isn't really an option here. So we're going to multiply n by 21, which is just 21n. And then 8 times 15, which is 120. I'm going to write out that 8 times 15 so you can see where I got that, since we're still kind of learning this here. So 8 times 15, 15 times 8, doesn't make a difference. Both of them equal 120. And the nice thing about this is that, once you get that cross products motion down and you write these products out, it's just a one-step equation again, right? Getting n by itself, the one thing that we need to do is divide both sides by 21. And 120 divided by 21 is 5.7142. We can round that to be 5.71. Okay? So what this tells us here is that 5.71 over 15 is equal to 8 over 21. That's the value we just solved for here, the numerator of that first fraction. I'm interested in checking this to make sure that we're right. How can we do it? How can we check this to verify? Aiden?
Divide 5.71 by 15 and then 8 by 21.
Yeah, compare the decimal values again, right? So 5.71 divided by 15 is 0.380666 repeating. And then 8 divided by 21 is 0.3809. Oh, it's a little bit different. Huh. For 5.71 over 15, I got 0.3806, and that 6 repeats. For 8 divided by 21, I got 0.3809. Does that mean I'm wrong? I mean, they're very, very close, aren't they? They're only off by, 3 ten-thousandths. But why are they different? Aiden?
Because the last number is different than the
Well, yes, I'm not asking you how are they different, but why? Why? I mean, if this is the value for n here, 5.71, I mean, I told you in PO41 that the decimal values are always the same. Why are they different here? What did we do earlier in the question that would explain why these are slightly off and not exactly the same? It's kind of one of those mathematical quirks that you always need to be aware of. Is 120 divided by 21 exactly 5.71? No. What did we do to the answer that we got for 120 divided by 21? Aiden? We rounded. When you round something, you lose a little bit of accuracy, right? 120 divided by 21 is not exactly 5.71, which means if we use this rounded value back in our original expression, it's not going to be the exact same thing as 8 divided by 21, and that's okay. Having that understanding to say, you know what, these decimals are super close, but why aren't they exact? Oh, that's right, we rounded earlier. That's going to explain it. Okay? Yes, Annika.
If you rounded it like on the test, then it was like that would have been
Totally acceptable. Yeah, no, totally fine. Yep, I would expect you to round this to nearest hundredth, and that'd be fine. Okay. All right, that third one there. What's different about this third one that we didn't have in the other two? What looks different about that third one that was not present or we didn't have in the first two? Yeah, Aiden.
After you find the n, you're gonna add 6 to it.
We've got other stuff going on here, right? It's not just n by itself in the numerator or the denominator of a fraction. It's n plus 6. Our process for cross products, though, doesn't change. We're still multiplying 10 by 27, and we're still multiplying 15 by n plus 6. But here's the difference. Because that n plus 6 is the denominator of a fraction, we need to add parentheses around it. Because we're not just multiplying 15 by n, we're not just multiplying 15 by 6, we're multiplying 15 by n plus 6. So this one doesn't end up being a one-step equation, because what do we have to do to get rid of those parentheses? What? Sorry? We multiply, but there's a special property that we call it to get rid of parentheses in an expression or an equation. Annika? It involves order of operations, but it's a special property, distributive property. Okay? In this case, because we've got that extra stuff with n, we've got to put parentheses around it, and we're going to need to distribute. So 270, which is 10 times 27, equals 15 times n and 15 times 6. That gives us 15n plus 90. Okay, 15n plus 90. Distribute that 15 into the parentheses, which means we don't have a one-step equation to solve here. We have a two-step equation. First, our 90 gets moved over to the other side using opposite operations. 270 minus 90 is 180. That equals 15n. A lot of you took retakes on this type of stuff last week before the end of the try. So if you have passed PO15, 20, 21, you're in good shape for this. Okay? If you have not passed 15, 20, 21, then you're kind of relearning that concept in addition to what we're doing now. That's why the POs are so important to stay current on, because we use them over and over again. Now we're at a one-step equation. Divide both sides by 15. And we get 12 as a value for n. Okay. If we wanted to check this, my first fraction isn't going to be 10 over 12. What's the denominator of that first fraction going to be? If I want to check this, I solved for n to be 12. What's the denominator of that first fraction going to be? Carly? 18, right? It's not just 12, it's 12 plus 6. So 10 over 18 equals 15 over 27. You could then compare decimal values to make sure those are equivalent, which they are. We can also simplify each of them pretty easily. They both simplify to be 5/9. Okay. Last one, same kind of deal as what we just did here. We've got extra stuff with that n variable. So cross products is still our go-to method. 18 times 10. And when we multiply that 2n minus 6 by 9, because there's that extra stuff with n, we've got to add parentheses. We are multiplying everything by 9. Not just the 2n, not just the negative 6, everything. Parentheses. So again, we'll be distributing here. 18 times 10 is 180. 9 times 2n is 18n. 9 times negative 6 is a negative 54. Add 54 to both sides. Opposite operations to solve for the variable. That gives us 234 equals 18n. Divide both sides by 18. Take n by itself. And we get a value of 13. Okay? Which, if we want to plug this back in to make sure it works, what will the denominator of my first fraction be? Not 13. What will it be? What will it be? What's 2n minus 6 when n is 13? GG? 2 times 13 would be 26. Then subtract 6. That's going to give us 20. So 18/20ths equal to 9/10. We can see scale factor pretty easily here. Divide 18 by 2 to get 9. Divide 20 by 2 to get 10. These are indeed equivalent, which means that our process worked. So I got a lot of head nods when I asked before if this is review from 6th grade, cross products. Are these second two here review from 6th grade, or are those new? I'm guessing they are the new piece. Okay, which we've done all that before. We've distributed before. We've solved two-step equations before. Okay, it's just now applying it into the new situation. So for tomorrow, here's what I would like. We're going to skip the word problems for now. I just want you to focus on the process here. I would like you to do 4 of these 8 for tomorrow. That's it. 4 of the 8 for tomorrow. None of the word problems, just on the second page. You've got 8 of them here. You pick 4. You see some of them have extra stuff. Some of them don't. You can decide how much you want to challenge yourself here. But 4 of the 8 homework for tomorrow. Questions, comments, concerns, comments, congratulations, or criticisms? Okay, so that's how you math.